Hello guys, today I'm going to introduce you to solar sizing. Our step 1, we look for energy demand. To look for energy demand, we ask ourselves how many loads are to be connected to our solar system and for how many hours in a day. Let's say we have two pumps, each operating 1 kilowatt, which will be pumping water for 3 hours in a day. Our energy demand will be, in watt hour, will be given as 2 pumps times 1 kilowatt, changing to watts. We multiply by 1000 times 3 hours, which will give us 6000 watts hour. That is our energy demand. Step 2, we look for the energy required from our solar system. Energy required from the solar system, which is given by energy demand times 1.3, that is losses factor, times 1.2, that is provision for connection of extra load. This enables us to connect an extra load when our pumps are working. The 1.2 provision for connection of extra load enables us to connect any other load to the system when our pumps are pumping. This will be given by 6000 watts hour times 1.3 times 1.2. So the energy required from our solar system will be 9360 watts hour. Step 3, we look for panel generation factor. Panel generation factor. To look for panel generation factor, we consider maximum number of hours of sunshine in a day in our region. How many hours do the sun shine in a day in the region of consideration? Let's say the sun will shine 6 hours in a day in our region. The sun shines 6 hours in a day in our region. So our panel generation factor will be given by the energy required from the solar system, which is 9360 watts hour, divided by maximum number of hours of sunshine in a day in our region. That is 6 hours. Which will be 9360 watts hour divided by 6 hours. Hour and hour cancels, so we remain with 1560 watts. Step 4, we look for panel required for our solar system. How many panels are required for our solar power system? Let's say the available solar panels in the market are of rating 200 watts. So panels required will be given by our panel generation factor, that is 1560 watts is our panel generation factor, divided by the available solar panels. The available solar panels, which will be 200 watts. Which will be 200 watts. Hence, panel required will be equal to 1560 watts divided by 200 watts. That is 7.8. That is approximately 8 panels. Approximately 8 panels will be required. Step 5 and our last step, we look for inverter sizing. The inverter to be connected to our solar system. In this, we consider the total watts of our appliances. We consider the total watts of our appliances. And in our appliances, we have 2 pumps, each of rating 1 kilowatt. That is 2 times 1, which is 2 kilowatt. Changing to watts, we get 2000 watts. 2000 watts is our total watts. So our inverter should be between 25% to 30% bigger than our total wattage. Our inverter should be between 25 to 30% bigger than our total watts, which will be 130 divided by 100 times 2000 watts. which will give us 2600 watts is